Review 1.5 on our three methods that we've talked about this chapter for counting different ways of doing a particular event, right? Finding our sample space, as it were. There are three methods. And the first one, again, is called a fundamental counting principle. We sometimes shorten that up to just FCP, and that means that we take n times m to get our total number of ways. All right, second one was called permutations. That uses the formula involving factorials. Remember, that's like taking all the numbers times that number all the way down to 1. And that's referred to as the NPR. And then there's combinations where we use, where order doesn't matter. So here's a little decision-making tree that should help you make, to know which ones to use when. First of all, the first question you need to ask yourself is, are repeats allowed? If you can repeat a process, yes, then we go and do the fundamental counting principle, okay? FCP, just multiply the different ways that there are together, however many there are. If the answer is no, you cannot repeat, then the next question you ask yourself is order. Does order matter? If the answer is yes, that you have to pay attention to the order of things, then we do permutations. Whereas if the answer is no, then we would do combinations. So here's some examples where we can practice going through that process. Ethel's grandma is sending a box of pears. She wants to select 2 for lunch. How many ways does she have to select 2 for her lunch? First of all, can you repeat? Well, obviously, if you pick one pear, you can't pick it again. So this is not the fundamental counting principle. Second, does order matter? Does it matter how she puts them in for her lunch? No. It just matters that she grabs 2. So this would tell me that we are using combinations, NCR. In this case, we would do 8, choose 2. Okay. I guess we didn't know how many boxes of pear there were. There was supposed to be of 8 pairs in the problem. Sorry about that. Forgot that critical number. So 8, choose 2. 8 factorial over 8 minus 2, which is 6 factorial, 2 factorial. And this is going to be 8 times 7 times 6 times 5 all the way down, right? And then it's going to be 6 times 5 times 4 times 3 all the way down. And then 2 times 1. Now the 6's cancel all those 6's, and that leaves me just 8 times 7 divided by 2. And 8 times 7 is 56. 56 divided by 2 is 28. You can use your calculator, and that will also take you straight from here to here too. All right, next one. Here we have some runners in a race, and there's 4 of them. How many ways can they finish? I know in our video there, it looks like there's more than 4, but we're just imagining there's 4. Again, first of all, can you repeat? No, a runner, once they cross, they can't come back and run again and get second place. Does order matter? Yes, it does. It matters what position you finish in. So this is a permutation. And again, we're taking from 4 things, we're picking 4. And so this would be 4 factorial over 4 minus 4, which is 0. And we know that 0 factorial is just 1, odd as that might seem. So this is 4 times 3 times 2 times 1, which I think I did that recently, and it's 24. So there's 24 ways for these runners to finish. Chris's password is made of 8 alphanumeric characters. How many choices are there? Again, can you repeat one of these 8 alphanumeric characters? Yeah. It wouldn't be a smart way to make a password, but you certainly could. So in this case, since we have a yes for that, then we're going to use the fundamental counting principle, which just says multiply 8 times however many choices you have. In this case, we have 26 letters in the alphabet plus 10 digits. That gives me 36. Now, if we included capitals as well, then we would have to take and add on another 26. So that would be 50, 62. So 62 times 62 times 62 times 62, right? And we would have 8 of these. So the shorthand notation is 62 to the 8th power. And if I grab my little calculator here, it's going to be a huge number, probably in scientific notation. 62 to the 8th power. Yeah, I get 2.18 times 10 to the 14th power, which is 218, and now I would have to add on 12 zeros. So there's 3, there's 6, there's 9, and there's 12. 218, I believe that's trillion. So that's quite a few different possibilities. Bag of leftover M&Ms from Halloween. There's 20 orange and 13 blue ones. If we pick 4, how many options can we have? Did not write that right at all. How many options? Let's just cross off the can we. How many options if we want 2 of each? Okay, so we want 2 orange and 2 black. Or 2 blue, sorry. All right, can you repeat? No, unless you want to lick a candy and put it back. That's probably not a good idea. Number 2, is order important? No, doesn't matter how we grab them. We just want 2 of each. So this is telling us combinations. All right, NCR. And order does not matter either. So no, no. All right. So in this case, we first of all take the 20 orange. And from the oranges, I want 2 of them. Why did I put an O? It should be a C for combinations. And then I'm going to look at how many options we have for the blue ones, and that would be 13. Choose 2. Once I get these 2 results together, I'll multiply them together. All right, because there will be that many for that and that many for that. All right, so I grab my calculator and I choose 20, choose 2, and we get 190. And then 13, choose 2 is 78. So times 190, 1,000, 14,820 options for, again, choosing 2 of each. All right, well, hopefully that helps you as you prepare for this test on Monday.